Appreciate that, John, kind of giving us the big picture across the estate and all the things that we're working on there. I'm going to be focusing more on Sellafield itself and on the decommissioning piece. My talk will be somewhat detailed, but I think it's important. You know, we're spending £2 billion of the taxpayers' money, and so part of what I want to do is just give you a real feel for what it is that we're doing to accomplish that. And I will echo the point that both Lord Hutton and John made. As we're doing this work, just speaking as the operator, we certainly recognize the wider context. We're focused on the hazard reduction, on the risk reduction, making the world safer. But at the same time, we understand there's a larger context in terms of demonstrating the back end of the fuel cycle can be managed, and we're all about that. So before I go on, I'm going to give a little bit of background for the Sellafield site itself. I understand that many of you will know all about Sellafield, but it has a history that goes back more than 70 years. It started out as a munitions plant in World War II, went on to have the original wind-scale pile reactors that were part of the defense mission there. The world's first nuclear reactor that took place in the 50s at the Calder Hall, on into the 60s and 70s when we had the Magnox repro work that got started there, on into the 90s with Thorpe, and then into the present day. You know, our plans now are to finish up the reprocessing mission here in the next 5 to 8 years or so, and we'll be fully into decommissioning across the site as we go on to that. The main focus that the decommissioning team is about at Sellafield is in the managing of the high hazard facilities, the so-called legacy ponds and silos. I would tell you that right now, I've been here about 5 years at Sellafield, and this is the most exciting time for decommissioning. We have been working on enabling activities for the last 10 to 20 years, and they're all now coming to a point where we're actually getting delivery on the site. And I'm going to show you some of that, but it is really an exciting time. I like to call it the end of the beginning. The beginning has been the last 10 to 15 years of getting ready, and we're now actually into the delivery portion of it. Picture right here is of the pile fuel storage pond. That was the pond that supported the initial pile reactors with the storage of fuel. It's gone on over the years to store many other types of materials, and in particular, a number of cans of oxide fuel. We had over nearly 200 cans of oxide fuel stored in this pond, and over the last couple of years, in partnership with the National Nuclear Laboratory, we've been able to remove all of that inventory. Just this past October, we got the last can out. That's a tremendous accomplishment. It's reduced over half of the radioactive inventory in the pond, and has been a key piece of risk reduction. This particular program, the pile fuel storage pond, has been probably the one that has made the most progress in what we call the decommissioning mindset. It's been a bit of a test bed for us to figure out how to be agile, how to take kind of an operational approach to doing decommissioning. Not necessarily, huge, large engineering programs, but more about how to think in terms of being agile, flexible, and getting the work done. The whole point of decommissioning, which many of you will know, is it's fraught with uncertainty, and time is our enemy. So we've got to figure out how to be agile, how to move forward. This program has done that more than any, and we're utilizing the learning from that to move on to the other programs. Example being the Big Brother pond, which is the first generation Magnox storage pond. This pond has hundreds of skips filled with hundreds of tons of fuel in it. It has many items of redundant waste items that left over from years of reprocessing, and it's now covered with about a meter thick layer of sludge all across the bottom. This sludge is a combination of materials that have just come in from the atmosphere. You can see it's an open air pond combined with corrosion products from the Magnox fuel that's stored in there. One of the keys is to get that sludge out. We need to do that for a couple of reasons, partly because it's the mobile inventory, so in an accident type scenario, that's a key piece we want to reduce from a risk standpoint. But also, we need to get the sludge out in order to enable to get the rest of the materials out. We have skips with fuel in it, and also things like zeolite beds and so forth. So we've been working on that for quite a while. In order to do it, we've come up with a couple of schemes. One of them we call our bulk sludge retrieval program. What I've got pictured here is in the foreground is a piece of kit hanging off of our skip handler, which is essentially a crane that runs up and down the length of the pond. We call that a corner guide. It goes and fits onto the corner of that inlet sub-pond there. You can see another one that's already in place in the background there. That piece of equipment then is the foundation for which we then build a actual retrieval mechanism that will allow us to pump the sludge out of the pond and into a purpose-built facility that's already been constructed to hold the sludge in a secure fashion. This is that piece that I was showing being flown in as it's being installed on the corner. Part of the reason I show you this is because of the need for the supply chain's innovation and help in this. This was designed, fabricated, tested off-site, was flown in this contaminated area and put in place, and it had to be right first time. If it didn't fit by an inch, it became a piece of intermediate level waste that we had to dispose of. But it was right first time. We've got it in. We would continue to go on and build the rest of that platform, and we'll be starting the bulk sludge retrievals in the spring of next year. In the meantime, in parallel with this, we wanted to get that sludge storage plant commissioned, and we also knew there were other pipelines and features that we wanted to get commissioned. So in order to get some early learning on the behavior of the sludge and the commissioning of the plant, we set up what we called a Plan B, which was a floating platform. This is going to be a permanently installed fixed platform. We put a floating platform inside that inlet sub-pond and got some initial results from that. So this is a quick video clip. So there's the floating platform. You can see the umbilical that goes to the control panel. This is a little bit difficult to see. What you're looking at is the underwater view of a pump that's attached to that floating platform. And it's actually dredging and removing the sludge off the floor of the pond. The picture's being taken from an ROV. We've been using ROVs extensively in both the ponds. This has been it's a historic moment. It was in March of this year we got the first material that was retrieved. A lot of work went into testing and simulating what this sludge material was going to be like, because the pumping mechanism itself needed to be able to have enough force to be able to lift the sludge up, but not too much that it just created a big plume. You can also see there's all manner of other debris in there, so we've got to have mechanisms to deal with that as well. So this has been working now since March. It's been allowed us to commission the packaging plant itself, and we're on with the bulk sludge retrieval that starts in the spring of next year. And move on now to talk for a few minutes about the Magnox Swarf storage silo. This probably has the largest portion of radioactive inventory in the LPNS programs. This facility has been added on to 3 times. There was an original portion and then 3 more extensions that were built. It was initially built in the early 60s. It's got 22 compartments. Each one of those compartments is, as you can see, is the size of 6 double-decker buses. That's how much waste is in there. There's 12,000 cubic meters of waste that's stored in this facility. The waste is partially the original swarf that was put in there, the cladding from the fuel, although a good bit of that has also corroded at this point and forms a sludge. So we've got a mixture of both sludge and the original material. And then there's all manner of other miscellaneous beta-gamma waste that's been discarded over the years that's part of what we're dealing with there. I have, this is the most complex of our programs. There's 3 main parts to it. The first part of the program is to maintain the asset itself. We'll need at least a 30-year life cycle of retrievals to get all the waste out of here. So we've got to make sure that the facility is robust and capable of managing that. So we've got a program to do seismic upgrades, to restore the electrical distribution systems, control systems. Done a lot of work on passive hydrogen ventilation. So there's a lot of work to maintain the asset, and the idea is that we want it, once we get started in retrievals, we don't have to stop and put a new roof on. So we're doing the roof and all that we need to be ready for retrievals. The second part of the program then is the actual retrievals mechanism itself. And what we're planning there is something we call a silo emptying plant, or a set machine. The set machine, the idea of that is there'll be 3 of them, and they will be mounted on the platform, the deck of the silo, and they'll run on rails, move from compartment to compartment, and they'll have a grab that will go down into the compartment, pull the material out, put it in a skip, and then the skip will be exported. So I've got a quick sort of animation that kind of shows that here. That's a kind of a conception of what the silo emptying plant might look like. This is a cross-section of the compartments. You can see all the different types of waste I mentioned. Some of them will have more than others. we have some knowledge of the inventory of the compartments, but it's incomplete. Better knowledge of the more recent ones, less knowledge of the ones that are older. And again, some of them, they're under a cover of water throughout. Some of them have the sludge material. Some of them have miscellaneous beta gamma waste type materials on the top. So we have to have a system that can retrieve all that. The concept is that this machine moving along the top, the silo emptying plant, can move from compartment to compartment, position itself over top of one, and then have a grab system that goes down in, picks up the waste, puts it in a skip, and then is exported from the facility. So we're on with actually fabricating that. This has been in play for, again, back to the end of the beginning story. This has been underway for 20 years. This is a facility down in Wolverhampton where these have been fabricated. There's actually two machines here. There's one on the left, one on the right. The one on the left is identified as SEP 2, and that's actually the first one out of the chute. This picture was taken around about the spring of this year. We completed the testing and commissioning of this machine in March of this year and began the disassembly to move it up to the site. It was designed and built and tested in a means to allow it to be taken apart in modules. So there's 23 modules that comprise this particular device. And so we've taken those, we've moved it up to the Kermit, which is a facility, a small village next to Sellafield. And there's a facility there where we're staging the items. It's a bit like taking apart a very large watch and then putting it all back together again. So the taking it apart bit is one thing, putting it back together and getting it all to work is something else. And that's the part we're on with right now. So as you can imagine, there's a base piece to this. The entire rest of the machine was built around. We call that the transfer tunnel. So that's a 50-ton piece of metal that was the core of all the rest of the machine. So all the other pieces came off first, and then obviously the last piece to come out was the transfer tunnel. The first piece that needs to go back into the silo is the transfer tunnel, and we just put that in 2 weeks ago. So I'm going to show you a quick clip of the transfer tunnel being assembled. So that's this big black box here, 50 tons being going up the hoist well through the hatch. It's 25 mils clearance on both sides to allow that thing to go up into the hatch. It's now been entered. This is the interior of the silo. This is the deck, and that's where it's being placed on the rails there. So that first piece has gone in. Again, a historic moment to get us started on the retrievals program. Since that piece has gone in, we've then have 2 more pieces that have gone in since then, and we're starting the assembly. Our target is to have this an interim halfway point of assembly by the end of the financial year and have it fully assembled and tested by 2017. So the plan then, I mentioned to you, there's 3 parts to this program. So the first part has been the actual the refurbishment and of the infrastructure itself. The second part being a retrievals mechanism, and then the third piece is a way to get once the material comes out, to process, store it, and make a disposable form. Our plan had been to encapsulate that material in a grout mixing type plant. That plant was SDP. Many of you will know quite a bit about that. It had several iterations. The most recent project we've been working on for the last year had actually been going very well in terms of progressing towards making a plant that would have a viable encapsulated product for storage. But in parallel with that, and you may have seen an ITV documentary that came along recently that was referred to that showed an alternative method that has been developed. It turns out the key to this alternative approach really has been an improved understanding of the chemistry, the hydrogen generation rates from the corrosion mechanism over the years. We've had a lot of help from across industry and academia to really underpin what the reduced hydrogen generation rates are. We think they're like a factor of 100 less than previously assumed. The better understanding of the waste behavior over time. And now, after this work has been done over a period of the last 4 or 5 years, we're at a point where we can confidently say that we can store this waste in a raw form in 3 meter cube boxes in a store for up to 50 years and probably more. We then think that we can also make a case to have a final disposable product that would probably be an entombed product versus encapsulated. We just put a capping grout and store it in that manner. By doing this, it's a much simpler process. Because it's simpler, it's much more reliable. It's also faster because we can start sooner. We don't have to wait for the processing plant, so we get into the risk reduction that much quicker. And it also it doesn't rely on the rate limiting step is not the processing plant, it's the retrieval, so we can finish faster as well, and it's less expensive. So we're actually able to do it better, cheaper, and faster. Rarely do you get all three. Having said all that, the key to all of it is the people. It's the skills in the supply chain, the skills in the Sellafield workforce, and we know that that's the key to the future. We've been working heavily in the young people coming into the site. We brought on over 170 apprentices this past September. We have 13 different apprenticeship programs. We have 2 new ones, one in health physics and one in project management. Just recently, we became the 100th member in the UK of the 5% Club, which is a commitment of part of Sellafield to have at least 5% of our workforce in the form of graduates and apprentices. So we know that that's just absolutely essential. At the same time, as has been alluded to already, the supply chain is the key to getting work done across Sellafield. Everything that I've mentioned so far has been done through the supply chain. None of this work that I've just described has been done within Sellafield. It's all been done in cooperation, collaboration, supply chain. I purposely try not to mention names of companies because I would just leave so many out. As John mentioned, there's hundreds of companies that have been involved in this. But the collaboration and the partnership of those companies is key to getting the work done. We have spent $1.15 billion last year in the supply chain, of which $1.14 billion was in the UK, and 20% of that was spent on SMEs. As you can tell, all of us are aware of the review coming out of the CSR last week. There's a huge amount of expectation placed on the NDA and consequently on Sellafield as a major player to be more efficient with the funds going forward. So it's incumbent on Sellafield. We need to become a better client. We need to get slicker processes. We need to be more efficient internally. We need to be a better understanding of what we're asking for. At the same time, we need the supply chain to be innovative and be flexible and be agile and help us achieve those goals. So I think collectively, we've got a huge commitment that's been placed on us by the government to get more efficient over the next few years and still be able to deliver the decommissioning mission. And finally, I would just say that we've come full circle. The Sellafield was the birthplace of the nuclear industry in the United Kingdom, as we described earlier, and now it's become the center of nuclear excellence along the West Cumbrian coast. We've got a real coming together from industry, from private industry, from the government, from academia, and the excitement about NuGen and the potential of Moorside project. With all that going on, I would say that the future of nuclear in West Cumbria has never been brighter. Thank you.